Good evening and welcome to the conversation. My name is Desmond. I am your host tonight. I would like to take this opportunity and thank Pastor Strike, who has had a trust in me for hosting the show. Pastor Strike has urgent family commitments and you would not be able to be with us tonight. I must say tonight we have extremely interesting discussion about vaccines, and we have Dr. Edison Mavundza, who is a pastoral doctoral research at Cochrane, South Africa, which is a research unit of South African Medical Research Council. Dr. Edison Mavundza holds a PhD in ethnobotany with the University of KwaZulu-Natal. He holds masters in plant science. He holds honors in botany and Bachelor of Science majoring in botany and zoology with University of Pretoria. Dr. Mavundza's research interests include ethnobotany, biochemistry, efficacy and safety of vaccines, and vaccine hesitancy. Tonight, we are going to have a very interesting discussion about vaccines. I think one would agree with me that vaccine has been an issue that has been in our mind. Some people might say this is one of the issues which we would say it's a mind-boggling issue to them. But it's a discussion that we must have, and we must talk about a vaccine because we can see what is happening around us today. Without wasting time, I would like to welcome Dr. Edison Mavundza. Dr. Edison, welcome to the conversation. Good evening. Good evening, Dr. Edison. Okay, I'm just going to unmute. Yes, you have unmuted your mic.
Okay. Good evening, Desmond. Good evening. Thanks very much for having me. And
thank you. Yes, Doctor.
Good evening to all the people in the Zoom. I hope you are seeing me correctly.
Yes, Doctor. No, we are able to see you, and would like to take this opportunity to thank you for allocating this time to be with us here at the conversation to unpack this issue of vaccine. I must say to our listeners that and our viewers that the issue that we're going to be focusing on tonight, we are looking at vaccine holistically, but we're not looking into a particular vaccine. We will not say we are focusing on this particular vaccine, but we are looking at vaccine in general. And the biggest questions that we are having tonight, Doctor, is what is vaccines? I think many of our listeners and our viewers would like to know, what is vaccine, Doctor?
Okay, thank you very much. Let me first share my screen. Thank you very much, Desmond, again. I think it's a privilege to be hosted by you. Unfortunately, Pastor Strike is not around, but I understand the circumstances. So before I can answer the question, what is a vaccine? Let me just share my screen. And please let me know if you see correctly.
Okay.
Yeah. Is it fine?
It's fine.
Okay. So before I can answer your question, Desmond, and then I think I would like to first indicate to the viewers or the panel or even the one who are watching on Facebook.
Yes,
that,
yes.
As you indicated before, I'm not a medical doctor. I'm just a researcher. So there are certain things that I'm not going to be able to give an advice on because I'm not allowed to do so since I'm not a medical doctor. So to answer your question, firstly, let me just indicate that the importance of research.
Yes.
Desmond and the colleagues or the people who are part of this conversation, there is indeed the importance of research. If you can look on my presentation now, you'll see that there is a mosquito. And the very interesting thing about this, on my PhD, I was doing my research, my thesis was on the medicinal plants, their uses on controlling malaria. So one of the section I was doing mosquito repellent plants, adulticide that. So one thing that I want to indicate to you especially from the research side, is if we didn't have a research, we will not know why the mosquitoes drink blood or why mosquitoes eat blood. The other factor is many people, they don't know that the mosquitoes, they don't have a sound. They don't cry, if I want to put it in a general language. And mosquitoes, there are female and males, but there's only one gender which eats blood, which is the female. So to answer this question, you need to conduct the research. So yes. I just want to indicate now that when you see a mosquito biting you, getting blood, it doesn't feed on your blood. It's the female mosquito that is using the blood to reproduce, to fertilize its eggs. And it's only female mosquitoes which bites people, which need blood. And the other factor, when you see on those wings, those are the things that are responsible for the sounds that irritate you at night. So that's what I wanted to show to you first, to indicate the importance of research. So if we didn't have a research, we were not going to know anything about these features.
Wow, this is interesting research, Doctor, because I mean, for me, it's the first time knowing that there are certain mosquitoes that don't bite, don't suck the blood.
Yes.
Yes.
Yes. So now I'm going to answer your, your question.
Of vaccine, yes.
Yes. Let's first understand what is a vaccine. So a vaccine is a biological product. That biological product gets introduced in a human being or in an animal, because the vaccine, they don't work only on human only. So it is a product, a biological product that gets into a human body. I'll just use a human body as example. And then when it's inside the human body, it activates the immune system. When it activates the immune system, the immune system fights back against the specific disease that has infected a human being. So that's what we call a vaccine. And what is the vaccination? The vaccination is becoming now a definition of saying is the process or is the process where the vaccine gets introduced inside the human being to fight infectious disease by triggering the immune system of a human being. And those immune system now, they fight back against the infectious diseases. So this vaccination, it has been regarded, or this process, it has been regarded as one of the most important public health interventions in terms of controlling the infectious diseases. And we are seeing this because around or between 2 or 3 million cases of death are being protected each and every year because of this. So now I'm talking about the diseases that can happen from infectious, from the pathogens. So if you are vaccinated or if the vaccine has been implemented in the human being, it's protecting close to 2 to 3 million people each and every year. So okay,
touching on the issue of vaccine, can vaccine just protect you completely from getting infected with certain diseases, or it just reduces the strength of the disease?
Yeah, it's kind of like a tricky. Now it can happen that it can do the both of them, both scenarios. But I think I'm going to touch on those things on when we're going on.
Okay, doctor.
Yes. So when you look at the vaccination, the impact that it has played, especially in the public health space, it has able to control the disease, and it also help to eradicate diseases or even eliminate diseases in other countries. So that's what vaccine and vaccination is all about. So I don't know if you want me to go on or you still have a question.
Yes, I'd like you to go on also into the vaccine and also talk about the vaccine preventable diseases.
Okay. So as I indicated earlier, that with the vaccination or the vaccine, we're able to protect or to prevent many diseases. If you can look at the screen here, these are kids or people with who are disfigured, especially on their legs. Excuse me. So what causes this? So these are the results of a polio. So these kids were infected with polio, and they end up having these features you're seeing here in this picture. So you can see that if the vaccine was given to these kids, this type of results were not going to be seen. This disablement that you are seeing here were not going to be seen at all. So that's why we are saying that the vaccine have played a huge role in public health. So going to another vaccine preventable disease, but before I can go there, I think I forgot to mention that in these pictures I'm going to show here, there are certain pictures which they are very not good for, I think, sensitive, what do I call it in TV?
Yeah, graphic would say that certain content it's more graphic, and I mean, if we have this kind of a content that is graphic, would request some of our viewers who are very sensitive to graphic content to perhaps mute or move away, grab a cup of coffee, because the section that the doctor is going to show us right now, it has a content that is it's very sensitive or very graphic content. So if you are very sensitive to that, it's a warning. It's a disclaimer that if you are very sensitive to this kind of content, would request that you perhaps mute your Zoom or walk away. Doctor, I think you may proceed and just unpack this whole issue of the vaccine.
Okay, thank you, Desmond. So the second, because I've chosen certain a few diseases that are vaccine preventable. We do have a measles. Measles is still a serious issue in other countries. So these are the result of measles. People who have been infected with measles, they will be having this terrible skin. So you can see look at the way the skin of the kid is being affected by this disease. So can you imagine if the kid was able to be vaccinated? So this was not going to be observed, or this was not going to be experienced at all. Even you look at the kid on top here, yes. Everything like her face was covered by the measles.
So touching on that issue, doctor, because I know it in South Africa that we are taking our kids to the doctor now and then for getting vaccinated for different. Is it one of them, or do we have one of those vaccines that are preventing kids from getting infected with measles?
That's true. That's true. And the funny thing about this is that when we're growing up, being a Tonga. When we were growing up, we're told that kids are going by someone. It's like they're taking a baby to being scaled, not mentioning that it's there for immunization or the vaccination. So these are one of diseases that are also vaccinated on kids in our country.
Wow. No, wow.
So you can see the effect that these infectious diseases are having when you don't have a vaccine. So this is the scary one that I think it scared me also. Even my body sometimes it gets itchy. So this is a smallpox. This disease has caused so many trouble. It has been with us as people for many years. And what happened here, it's the way it was causing havoc all over the world. It was estimated that 10 people, 3 people will die because of this smallpox. And those who survive this, they will live with the terrible scars of this disease. You can see, even, I don't know if you can have someone will be saying you can apply a bio oil or any chemical to remove this, but the after effects of this were very terrible. So this is a type of vaccine preventable diseases.
So we are saying that the vaccine would help prevent this kind of diseases, like smallpox.
Yeah.
If we take kids to be vaccinated at the right time, they would be prevented from getting a smallpox.
Yeah, that's why we are saying these are vaccine preventable disease.
Wow,
so it shows that the people, these people were not vaccinated. So now I am going to talk. There is something very interesting about this one, and I apologize for showing this, but this is science. This is what we are dealing with. So what is this? This is a human papilloma virus. So as you indicated, I'm a researcher at Cochrane, South Africa. So basically, we are doing the evidence-based research on this, and on. So for me, it is a topic of interest. So I'm doing a lot of, and I've written a paper, I think 1 or 2, on 2 papers on HPV and HPV vaccine. So what is HPV? HPV is a human papilloma virus, and it is like a sexual transmitted disease. It can affect anyone. Many people who are affected about this, they are not showing any symptoms, and like they just disappear sometimes. But if the infection is high, you end up having the symptom, and then you get diagnosed with it. And you can see here on the left, this picture. These are the results or the symptoms of the person suffering from HPV. You can see that, hey, this is terrible. And then here, if I'm not mistaken, this is I don't know if I'm not gonna call it posterior end, or in biology term we just say posterior end. So it's an anal infection. Wow. And most of these, they happen to sexual active, especially men who are having sex with another man. In most of the cases, they happen there. And then you come here. These are the...
I wanted to come in there, doctor, and just ask you, with these diseases, can someone die from this HPV disease?
It is very possible to die from this HPV if it's not treated. And I must indicate that, it's just that I didn't indicate here. If we talk about cervical cancer, one of the most important cancer amongst women, it is caused by HPV. So you can see that it's a very dangerous disease indeed. And you look at this one here, the genital wart. You look at the female reproductive organ. It has been showing the warts here. It has been infected. Even here, the male organ, reproductive organ, it's also having this HPV. So all these diseases that I've shown here, all of them, they are vaccine preventable. If someone has been given a vaccine, the chances of you not getting this thing, it's 90% or more. You are safe from this disease.
Wow.
Excuse me. So I think I'm done about these vaccine preventable diseases.
Yes, I think we can also talk about, we spoke about vaccine eradicated diseases. If we could also, touch on vaccine and the discovery of the vaccine, if you could go into that.
Okay. So as I indicated earlier, that vaccine have eradicated some diseases, and vaccine have eliminated some diseases in other countries. So what do we have here? It's a smallpox, the one that I was showing earlier, that it's a huge, it had a huge impact on the people's lives, and many people died from it. And then those who lived, they had the scars to show, which were very bad. So vaccine eradicated disease, I'll be only talking about smallpox. To the best of our knowledge as a scientist, the only disease, and I stand to be corrected, the only disease that has been eradicated in the whole world, it is a smallpox. This disease was eradicated in 1980. And you see the gentleman here.
Yes.
This gentleman here, his name is Ali from Somalia. He was a cooker. And he was the last person to be infected with the natural infection of a smallpox. And the disease was eradicated. And how did they eradicate it? They eradicated it because the World Health Organization had a plan, and then they sat down in 1976, I think 1980, something, no, 67, if I'm not mistaken, to put a plan on how do we deal with this smallpox. And then everyone sat down and they came up with a plan. Let's do the mass vaccination. Mass vaccination is where like people, they go all out and vaccinate each and everyone. And then at the end of the day, they were able to eradicate this disease. So this guy you're seeing here, this was after the what do you call this?
After getting after getting healed from the smallpox.
Yes, after healed.
Recovering from smallpox.
Yes, and then unfortunately, I think I can say he's the face of smallpox. But however, unfortunately, the guy passed away in 2013, and the reason for is that he was infected with malaria. So you can see, we can say the guy was something else. His life was, because you get infected with the smallpox, you win against smallpox, you get infected with malaria, and you lose the battle. So that's what happened. So I must reiterate again, the vaccine eradicating a disease that we know now in the whole world, it is smallpox. So these are this we are trying to show to you that the huge part that the vaccine has played so far. This is if there was a gold, bronze, and silver, this was going to be given as a vaccine. This smallpox vaccine was going to be given the gold medal for this.
I mean, it's great to hear that, vaccine was able to be more effective in eradicating smallpox. And I wish that, we could have vaccines that are able to eradicate a number of diseases. I mean, you hear a lot of people talking about when are we going to have a vaccine that will eradicate, HIV, cancer, the disease that we've been having for over 100 years, So we are hoping that, our scientists and our researchers, would be able to sit down and come up with a vaccine that would be able to, eradicate those diseases like what they have done with the smallpox. And I think if they've done with this, I mean, this is a clear example that they would be able to do with the other diseases if they put more effort into it. So I would request you to continue with the presentation with the vaccine eradicated disease. If not,
that's true, because if we're able to eradicate smallpox, with a small technology or with a little technology that we had, can you imagine what we can do now with the improved technology that we are seeing in the whole world now?
Absolutely.
So, yes.
Yes, doctor. I would also, you can continue the presentation of the vaccination.
So now I want to talk about, to show like how does this vaccine work. Remember we said vaccination is when you give or you introduce a vaccine, which is a biological product in a human body, and then that body now responds by producing antibodies to fight that disease. So how does this vaccine work? So a vaccine has been produced, so it gets injected to a human body. When it gets injected to a human body, the body now realizes that, hey, I've got an outsider here. So what does it do? The body produces the antibodies to fight that disease, not a disease, because the disease is caused by a pathogen. So it fights. Now it releases the antibodies. Remember, the vaccine, it's not a real disease there inside the vaccine. So what happens now is just mimicking. I don't know if I can, just to make example, because I want people to understand this part here. It's like our South African National Defense Force training to protect the country. When they go fighting on training, you know, they are busy shooting. They are busy shooting at something that they are imagining, or they've got an enemy in front of them.
Yes.
So that's what happens with the vaccine. So this vaccine that has been produced now, I will be talking more about the vaccine, how it's being produced. But this vaccine here, it is mimicking. It's like we are having the virus that produces this that causes a disease. So this virus here, remember, it's a mimicking one. It's not a real virus. It's not living.
Yeah.
So when this virus enters the body realizes that no, there is an outsider here. What happens? It reduces, or it produces the antibodies to fight the virus. So as I told you that this is not a real virus. So these antibodies now, they've been produced. So what happens when later the real virus comes, it wants to attack you. The body has got something scientifically, because I don't want to go deep down in a science world. But now when you encounter the real virus, the body remembers now that, no, this is the same people who came, so I know how to deal with them. So that's how they fight the virus.
So we can say, sorry to come in there, we can say that the vaccine works like when you have a laptop and you have an antivirus where you install it onto your machine, so that the day that someone plugs in a hard drive or memory stick with the virus, the antivirus is able to fight against that virus. Are we on the same page if we were to say that the vaccine would be the same as the antivirus? Yes, doctor.
It can like similar. So when those antibodies now comes, remember the antibodies were triggered when you introduce the vaccine, which has got the mimicking virus, not the real virus.
Yes.
So now these antibodies, now they say, oh, that person is coming. Remember, in a scientific world, we'll be saying the virus, how the antibodies detect this, they use their structures. They know, okay, it's coming like this, and then, oh, that's what, okay, that is malaria, that is measles. That is, so these viruses, they've got the specific identification characteristics. So these antibodies, now they see, okay, they say, okay, it's coming. They produce, the body produce the specific antibodies for the specific virus or a disease itself. So at the end, after those antibodies, so you don't get sick and you are immune. So that's how the vaccine works.
Wow.
I'm done here.
Very interesting.
So everyone wants to know exactly when was these vaccines were discovered.
Yes.
So the vaccines were like introduced or discovered by this gentleman here, Dr. Jenner. We call him James Jenner. So this is the father of vaccines.
Where is he from?
What happened?
Which country is he from?
He's from England.
Wow.
You know, you'll forgive me. I've got a difficulty in identifying Britain or England or something. Yeah. So this guy, he discovered the vaccines in 1796. He was a doctor then. So how did he discover this? So you will see that this smallpox was a very dangerous thing, because he discovered the vaccine based on the smallpox. How did he discover it? There was a farm where the milkmaids, the people who were busy milking cows there, they will have a cowpox. Cowpox is similar to smallpox, but they don't infect. It's like, and it's not a smallpox as a whole, but it's similar. They're from a same family, if I'm not mistaken. So the people who are milking there, they will get this smallpox from the cows, but they were not infected by smallpox. So the guy started to do the observation. He said, okay, wait, these people, they are having a small cowpox, but they're the only people who are not infected with the smallpox. I must do the experiment and see. So that's when he did the experiment. How did he do the experiment? There was his worker, the gardener. He took the 6-year-old gardener, a son of his gardener, and he inoculated. He went to, remember the cowpox, it will be like a blisters here. So he took the pus from the cowpox infected person, and he inserted that cowpox infected pus to the small boy. And that small boy was then observed for like several days, and it like was exposed to the smallpox environment to see if he was going to get in smallpox. And miraculously, the boy didn't get smallpox. And then we further tested this on more people, and it did the same thing. People who had the cowpox didn't have a smallpox at all. So that's when the discovery of these vaccines were made. So until now, the methodology just kept changing, but the background of vaccination, it's coming from this gentleman, how he did it. So and then very interesting is the same vaccine that were able to eradicate the smallpox. So you can see like just a simple mindset that he had, no technology, no nothing, by looking at people. So these ones were having cowpox, but they don't get infected with the smallpox. So let me see what. So you see, he discovered a vaccine, and then he was able. So you can see here, even if they say smallpox is eradicated from the world. So this was his work, James Jenner. So we call him the father of vaccines. So that's how the vaccines were discovered.
Doctor, I would like also to go into the types of vaccines, because I believe that we've got different types of vaccines. If you could also take us into different types of vaccines that we are having.
Thank you, Desmond. So, as I said earlier, that when the vaccine gets injected in a human being, it's not a real virus or the real bacteria that gets injected in a human being. It has been processed in a laboratory. So there are different kinds of vaccines. They differ with the disease or with the vaccine themselves. So here, this is too scientifically, but I'll just touch, I'll just touch 3 of them. So we have got something called the live attenuated. So what does we mean when we say live attenuated? So we are saying this vaccine was developed or was manufactured or was developed or originated from the virus or the bacteria, or I'll look at the virus now, or the virus that was alive. But what happened? They went to the lab and then lessened or weakened, weakened the virus itself. There is a processes that are done in the laboratory. So remember, when vaccines are being made, these viruses is the same viruses that they get isolated from a human being. So now this morning you are sick with, let's say, COVID. I'll just make an example. So when we want to study the COVID, they will isolate that virus from your body. So that's how. So when they say live, it's like it's the live virus. It's still the live virus that is, it's the virus that they got from your body, and they weakened it. It's no longer it doesn't have the more power like it used to be, but it's still alive. So The attenuated means it has been weakened. So there are vaccines that are made like this. Excuse me. So we go to the inactivated. So this is the whole virus that has been isolated. However, this virus has died. It is not living. So remember, I said to you, the antibodies, they detect the antigens or the pathogens or these viruses through their structure.
Yes.
So when they come, sorry?
Yeah, no, you may continue, doctor. You may continue.
So when they come, even if it's dead, but when it gets introduced in the body, the antibodies will be released by the body because it has seen the structure or the certain particles that are there in the virus. So we have got a subunit here. So these are the viruses or the vaccines, meant to say, which are made from the certain part. It's not the whole virus that is being injected. They take a specific part. It's like when I say people from, let's say, we identify people who are with a specific characteristic. So they will pick a certain thing in a virus itself and introduce it to the body, and the body will release the specific antibodies for that virus. That's what I can say. Anyway, with the DNA and mRNA, it's just a technique. It's very, it is like kind of like scientific, yeah. But it's one of there are so many what do you call this? Many vaccines that are developed through this method. Yeah, and then what I can think now is the current vaccines that we are currently looking at, the COVID vaccine, most of them, or if not all, they are done through this process, DNA and RNA. Thank you, Desmond.
I just want to come in there to all our listeners that are listening to us on Bold Moves Radio and the listeners that are watching us on our Facebook page. I want to suggest that if you've got any questions that you'd like to pose to our doctor, you may start putting it on our Facebook status or logging into our Zoom and post those questions, because shortly we'll be, going into the questions, and Doctor is here. He will be able to clarify some of those questions. Thank you, Doctor. I think we can continue and move into the development of the vaccine.
Thank you so much. So here, Desmond, and the viewers and the listeners, this process of developing a vaccine, it's not a simple thing. It is a long process, very difficult. It is being said that it can take 10 to 15 years to happen, because wow. You look at some vaccines living now. We don't have a vaccine for certain what do you call this, certain diseases.
I just want to come in there, Doctor, just to also, and perhaps you'll be touching on it, but why does it take so long? I mean, I'm looking at years, 10 to 15 years. That's such a long time. Why does it take so long to develop a vaccine? I mean, over the years, we're looking at 10 years, 15 years. Why does it have to take so long to develop a vaccine when we have so many machines in this day and age?
Okay, that's good. So I think, as I indicated, that it takes so long, there is stages for this. So if you can look here, there is an exploratory and preclinical. So this is where many things start. Here, it's where we call a class or a lab, where you are having a disease, and then people, they put their head down. Remember, I spoke about the discovery of vaccine. So yes. That's where things get started. So you must know, okay, what type of disease is this one? What is it happening? What is it doing? So you study a lot of things like who is it affecting? What are the outcomes? You see, so that is the process. It can take 2 to 3 years with the inclusion of preclinical. So I will first like to talk more about this section here, exploratory and preclinical. Exploratory, as the word say, you're exploring. You want to see you want to learn more about the disease, even about the virus itself. What kind of viruses do you must first identify it? What does it use? It affects who? It's all those things. And later, when you have seen that, you sit down, you come up with the process, like, okay, we are going to test this disease, or we are going to come up with a vaccine which is going to work like this, or with this road, doing the DNA. Remember, I just finished speaking about the type of vaccine. So you must know, I am going to use inactivated or the subnuit, so it's many things. So that's the way many things are being studied and explored. So you come to the preclinical. Preclinical, it's where you are doing your cell culturing in the lab, and you test this on your animals to see, like, what is it? Do you have activity? Is it coming okay? Excuse me. And when you are done with this, remember, and these things of a years, 10 to 15 years, it gets affected because you are not just doing things alone. You must have approval to do these things.
Yes.
You do it, you submit to other people to say, okay, we agree, it's okay. Remember, when you do this experiment, you don't do once. You must replicate. You must see if it's working or not. We don't want to be in a situation where things are just work that day and then tomorrow they're no longer working. So we come to remember, now you are done with the lab and then the animals. It has passed the vaccine candidate. Remember, now it's not a vaccine, it's a vaccine candidate. Now
so
it goes to
are you saying that, sorry to come in there, doctor, are you saying that this vaccine development, you started first with the animals?
Yes.
You started first with the animal to explore if the vaccine is effective. And once we are sure that the vaccine is effective, we then put it into people. Okay, doctor, yes. You may continue.
Yes. So when you move to people, you don't just go to the people as a whole. You go to people. So we have got something that we call phase 1. It's a clinical trial. Remember, animals, it's a preclinical trial. So with the phase 1 clinical trial, you have got people who between 20 to 100. And between these 20 to 100, you want to see now the safety of this vaccine candidate. You also want to see the immunogenicity. So when I'm talking about immunogenicity, remember we said the body react by producing antibodies. So we want to see that level. And when you are done with phase 1, it gets approval also to go to phase 2. Phase 2, it's when you look at hundreds numbers, between 800 to 1,000 or 1,000 people. And remember, these people are healthy, all of them. You don't put people who are not healthy at all. It's a healthy people, certain age.
But why? I just want to come in there. Why choose healthy people?
Because you don't want cofactors. You don't want cofactors. When I'm saying cofactors, I mean you don't want to think that someone who's, that's why they've got the limit, the clinical trial. They put until 65 or 60 years. They will say 17 or 18 years to 60 years. But you need to be healthy in order to take or to participate in this. So they don't want people with disease, because you find that maybe the vaccine, it reacts somehow in a disease, in the presence of disease, and then you find the false result.
Okay, you're touching some very important issue here, which I want to really touch on it. Can someone be vaccinated, going to be vaccinated with maybe low immune system or having other chronic diseases, and due to the complications of that vaccine, that person, can they lose their lives by just getting a vaccine? Is that possible, doctor?
No, I wouldn't like to get there much, but what I know with my little knowledge about the vaccine, when you get to the office of a doctor or the family medicine or whatever, they will ask you some questionnaires to see that, are you eligible for this vaccine? Remember, when the vaccine has been approved or it has been licensed, by certain authority to be used. It has got the directions and uses. We call it the direction uses or terms and conditions on it.
Yes,
that people like this, they don't have to. If you are like this, you can't do it. So those are the things that will happen. So if the person, they will ask the person, even now many people who have been vaccinated with COVID, they will tell you, when you get there, they will ask you, are you pregnant? When was the last time you had a vaccine? So those things, those questions, they give the person who need to vaccinate you the clear picture. No, this one, it's not suitable for vaccination.
But what I would like to know is the implications of vaccinating someone who has this chronic disease, or who has what would be the implication? What would that vaccine do if the person perhaps lied to the doctor, or perhaps the doctors were not able to ask those questions? What would be the implications of that, doctor?
I think the implications will be around adverse events. What we call adverse events, it's the side effects that you will see after vaccination, maybe sometimes after being vaccinated. And can it lead to serious adverse events? I think so. It can lead to serious adverse events if your immune system, it also depends on a human being here. Because some people, their immune systems are strong, but you can get sick or end up even losing your life because you'll be contradicting what has been said, that don't give this.
So we can say that different vaccines would come with the certain side effects, and what you're saying to us tonight is that if you get vaccinated, having low immune system, having certain chronic diseases, there are chances that you might be very sick to the extent of you losing your life. And I think it's very important tonight that when people, whatever vaccine, people will go and get vaccine, which we've seen how vaccines are effective over the past years. They were very helpful in eradicating a lot of diseases. But what is very important, what is very crucial, is that those questions need to be asked. And if you are not eligible to be vaccinated, you should not. It should not be a question of let's push numbers. We want to get to certain numbers in a short period of time. But it's a question of, are people who are going to be getting the vaccine, are they also eligible? Let's get people who are in a position to be vaccinated for whatever vaccine people are going for. And I'm happy that you've clarified on that issue. I think I would allow you to continue, Doctor.
Yeah, that's true, because as you can indicate, the terms and conditions.
Yes, terms and conditions.
Written that you don't do this, So on phase 3, that's when you are dealing with the many people. And what are the reason for doing a phase 3? You want to see the efficacy.
Yes.
You want to see what do we say about efficacy? When we say efficacy, we want to see the disease showing up on people. Let's say it's a COVID we have given on phase 3. We want to see if they say efficacy was 80%. It's like those people who were vaccinated, 80 people in 100. 80 people in 100 didn't get the disease. So that's what we want to see on phase 3. And we also want to see the safety. We want to see the safety. Is there any adverse events that will come here? Are we going to have people coming up with serious adverse events, or is going to be only a normal side effect? So that's what happened. And then when this phase 3 is done now, remember, you have to submit your data or everything to the authorities to approve this vaccine candidate. So that's when it will take between 1 and 2 years. And yet it's a process, because there are certain things that need to be followed in order to do this. And later, after it has been approved, that's when you do the manufacturing. But I must indicate now, remember we spoke about phase 1, phase 2, and phase 3.
Yes.
Manufacturing, after getting the license, after you got your license, you go to the manufacturing, you manufacture now.
Yes, yes.
There is something we call post-marketing surveillance. This is a phase 4 a clinical trial. What is this? So there are people, now it has been licensed, even though that the vaccine, it has been given a thumb up, there is authorities that look at side effects or any effect that will come or will appear after the vaccine has been injected to a population. Not, remember I spoke about people who are in these trials are specific people, are healthy. But now you are introducing the vaccine to the masses. You are introducing the vaccine to everyone, regardless of their health status, because now you have got someone who's got a TB or someone who's got the, you were talking about immune system or whatever, but these people, remember, on the clinical trials were healthy ones, were selected on the specific conditions. So now, because the vaccine is out there, it's gets injected to everyone. That's where they still look at it. And I must indicate to you, Desmond, and the listeners and the viewers also, yes, this thing of post-marketing surveillance, it really worked. There are, it's just that I didn't put vaccines here, but people who are more interested on seeing this, you can go and Google or go to check, do your own research and check on the specific vaccine which were recalled after they've been approved and getting given to people, only to find that later they have got a certain consequence, negative consequences.
Yes, I mean, I'd like to, because I see also that we are running out of time, and you know, I also like you to touch on vaccine hesitancy and also touch on those vaccines that you spoke about. You spoke about the vaccines that were given to people, but later on they've realized that no, we've given people a vaccine, but you know, after maybe, I don't know, a period of a year or 2 or 3 years, we realized that this particular vaccine has a side effects. What were those side effects, if you could just touch on them in a nutshell?
Yeah, normally you will be thinking of the certain diseases appearing.
Yes, yes.
I remember, if I'm not mistaken, because I'm thinking from top of my head, there is a vaccine, I think it's oral polio, something about oral polio. It was given to people, and they had to recall it because people who were getting that vaccine, they have a certain condition. And remember, I want to emphasize here, when a certain condition is peaked, after getting people a vaccine, they do a study, they do a research. They want to see if this vaccine, is this a vaccine-related condition or it's something else? You don't just recall it, you must do the investigation. And when you do the investigation, you find, yes, this is 100% related to the vaccine. That's in most cases they do. But there are certain conditions, and I apologize for not picking this vaccine which have been recalled. But there are certain conditions where they will do the what do you call a risk and what? I forget this name. When you are assessing, when you gain something, a risk and benefit and risk, you find that 1 in 100,000 people after taking the vaccine had this condition. So yes, what the conclusion that will be made from there, it will be, no, we assess the benefit versus risk. So which means each and every million people, maybe to say, there will be only 1% suffering from this condition. So they won't be able to recall that vaccine. But if it shows that maybe 70% or 10%, I can't tell a specific number, but if the impact is huge of these negative effects of this vaccine, that's where the vaccine get recalled. So, and I must say also, I apologize for but those who are interested on seeing exactly why this, which vaccine were recalled, they can go and Google them and just vaccine recalling. You'll see the type of vaccine and the process that was followed to recall this vaccine.
So, Doctor, I'm afraid we are running out of time. So I'm just going to give you
yeah.
time to go through the presentations, because some of our listeners have asked very important questions on our Facebook page, so which I would like to go into them. So if I could just give you time in a nutshell, go into the presentation, and once you're done, then we can just go into some of the questions. And I would ask you also to extend our time. I thought by 8:30 would be done, and we haven't gone into questions. So if you could just go to the presentation, then we'll go into the question and answers.
As long as they don't arrest me, because I'll be driving back home at night.
You're an essential worker. You're a doctor. You're an essential worker.
So now we remember, now you have been vaccinated, but how long does that vaccine last on you? How long are you protected? That's a question. Yes, so there are certain vaccines, but they differ. Some vaccines, they are lifetime. You get injected once, boom, you are safe. But some vaccines you need to get a booster vaccine. And when I talk about the lifetime vaccine, I talk about measles. When you get measles, it's a lifetime vaccine. Yes. But when you talk about flu, we all know flu every season we vaccinate. So that's what I wanted to show only. Even these pictures you can see, when you get vaccinated child, it's 100%, it gets to 70%. You see, it's disappearing with your age. So you are vaccinated now. No. You have got the thing. Now I want to show how do you get this vaccine. So there are several or 4 ways of getting this vaccine in the body. There are some vaccine which can be done orally by drops in the mouth. And the vaccine, these are the vaccine here. You can do the influenza, hepatitis B, A, your HPV are done intramuscular way. And the subcutaneous ones, you do the measles, it's the yellow fever, and this one. And this one, there is an intradermal way of injecting a vaccine in a human being. And one of them is a BCG. So BCG are those vaccines that are normally used in is it a forearm or what here on our shoulders here. So here I'm trying to show you the way needles are injected in a human being. Many people, they will be surprised, like why government said this first month will be training the health workers how to inject this vaccine. As I indicated to you, the oral one, I think, is very simple. But look at the intramuscular one. Intramuscular one, you must inject the vaccine deep down to the muscle. That's why when someone will say to you, hey, I think they hit my bone, I felt that needle on my bone. That's how they inject the intramuscular one. The intramuscular one, the way now we are getting our COVID vaccine is done this way. And you have got the sub one. Sub one, you have to hold the what do you call this, the needle, and inject it in a 45 degrees point. Even this one of an intradermal. So these are the ways I was just indicating to you how this vaccine gets in. It's not the same vaccine. Not every vaccine is going to be given through a needle.
I would prefer the vaccine that is the oral one. The injection, I'm scared of pains, I would prefer if I just walk in and they give me some medication to drink and not go through this pain of getting the vaccine.
Yeah, so you see now when you were talking about the exploratory section there, we're talking about why it takes too long. You see now we have got even this section of a administration road. It makes a huge impact there. if you study even how are we going to inject this vaccine, because it's not going like it's not every vaccine that's going to be given on a forearm or on the shoulder. Yeah. So I think I'm going to the safety effect of this. So after, I must indicate that just like any drug or any medication, vaccines are not 100% safe. Even if they can be 100% or 90% effective, but they are not safe. Why I'm saying they are not safe? After being injected, you can have a side effect. What are those side effects? Remember, I just finished talking about the roads of administering this vaccine. The part where they injected you, it can get sore. It can be, I remember I've seen many people who got is it a BCG or a smallpox or polio, I can't remember, but they've got on their shoulders, you will see that there is some of them, they've got the scars now.
Yes, yes.
Yes.
So I got one of those growing up, the nurses used to come to our school and they used to, give it to us.
Yes, BCG or polio or something. I can't remember which one has got a round stamp. And then some people when we were kids, we didn't know, we thought like, no, the people from Mozambique, they had it here in their hand, as it's here. So we thought like, if you are coming from Mozambique, you have to be here, and then, yeah. So at the same time, you can feel mild fever, you feel tired, headache, and then you have got aches on muscle or a joint. But remember, these side effects are minor, and they can disappear in 2 or 3 days. And you have got adverse events. So these are the events that appear when you have just vaccinated. Maybe after 3 weeks, you get to be admitted in the hospital. So, and yeah, so these are the side effects and adverse events that you can get from a vaccine. And I think you said I must talk about vaccine hesitancy.
Yes.
As I mentioned earlier that James Jenner is a father of a vaccine. This picture was taken sometimes, long time ago. I think it was drawn. So what is happening here? Or let me just say first, although these vaccines are effective and safe, most of them or all of them that get given to people because they've been approved, there will be always people who are against those vaccines. Yes. And the people have got different reasons. Yes. One reason, it can be a religious reason. Second reason, the main reason that we have, because this is affecting the vaccine coverage, because you asked me about herd immunity. If you don't have a certain number of people getting vaccinated, you won't be able to get a herd immunity. You see? So what happens? There will be less people getting vaccinated. And what are the reasons for that? There are people we call the anti-vaxxers. These people, they have got their way of being anti-vaccine, talking things every day, talking that the vaccine is going to be, one thing that the anti-vaxxers mention a lot, it's because one thing that you know, I think, if you can tell a man that you are going to be infertile, yes, it's something that men don't like in the whole world. You can't tell a man that you're not going to get babies. You tell a woman you're not going to give birth. You see, so those are the two things that we think many people, they always, the anti-vaxxers, they will be always the after effects. So if you look closely on these pictures, sorry about those one who are just listening. So this picture, it's about, this is Kris Jenner here injecting a woman. But this, look at the people around him. Because remember I said, the vaccine of a smallpox was developed from the cowpox. So they've drawn the cows coming out from the faces, coming out from the backs of, you can see the heads of the cows here, people getting horns, you see. So this is a vaccine. So to show you now, even today, when you have got the vaccine hesitancy or negativity around the vaccine, it's not a new thing. It has started 1796, long time ago, when the vaccine was being developed. There have been people who were saying, no, this vaccine are going to kill us. This vaccine, we all know now that there have been many stories around the COVID vaccine. So this is the challenge of the vaccine. So coming to my summary and conclusion, yes, I think since the time is against us, I'll be saying we understand now through my presentation, we know that the vaccine, their work is to trigger the immune system and to produce antibodies to fight the vaccine. And these vaccines have played a huge role. They have eliminated diseases, they have eradicated diseases. It saves close to 2 to 3 million lives every day once you get vaccinated. And you can see even now when our current situation, people who are getting vaccines now, they feel confident that no, Mina, I'm vaccinated, I won't get it, I won't get, you see. So now we can see that the vaccine, it is still, even it has been regarded as the most important public health intervention. I will be ending and saying now that the vaccine, it is still a public health intervention that is still going to continue million years to come. And many diseases are going to be eradicated and many diseases are going to be eliminated through this. But the challenges are there. What are the challenges? The hesitancy, as I indicated that my research interest is on hesitancy. So yeah, that's, I think I'm done.
Okay, Doctor. Thank you very much. I'd like to appreciate the presentation, a very informative presentation that you've put together. We really appreciate, and I think most of us, and I myself, I've learned a lot about vaccines tonight. So I'm just going to go through some of the questions that have been posted on our Facebook page, and then you can just go into them in a nutshell so that we don't waste time, because I think the time is against us. I've got another question here on our Facebook page. Sue Shauke is asking, how long must one wait to be vaccinated for COVID-19 after recovery from COVID? And then the second question is, so it takes over 2 years, so the COVID vaccine was manufactured too early. I think that is just a comment. I just want to go, why don't we have a vaccine for HIV? That's another question. Do you want to just answer these questions in a nutshell, and then I can just go into them few last questions?
What was the second question?
The second question, okay, we've got why don't we have vaccine for HIV? And the second question is, I think the second question was more of a comment than a question, because the Batiam Mutati, the question was, so I think it's a comment. It says, so it takes over 2 years. So the COVID vaccine was manufactured too early. I think it's the issue that you are talking now about vaccine hesitancy. Yes, I think you can just answer those few questions and then we can continue to the other questions.
Thanks for this question. I think I'll start here from the last one, why we don't have HIV vaccine. If you can remember when I showed you the process that is being followed when you are developing a vaccine, there is a stage 1 where it's a exploratory stage where you are studying these viruses. And then on studying on them, you want to know how are they causing this? How I'm going to develop the vaccine for this? How is going to be injected? So the hurdle for doing this, it's still on that platform of saying, because we know that in South Africa, if I'm not mistaken, Cape Town, if I think, Prof, in Cape Town, there have been some trials, if I'm not, they are working on the clinical trials of HIV. I'm not sure how far they are now, but it is an ongoing thing. It's just that there is no approved thing. It is still, when we say clinical trial, remember, we're talking about the development stages of this.
Yes, yes.
It can be still on an exploratory. It's just that the disease itself, it's a challenge. The virus itself is a challenge. They can't tell how do we approach it. That's a problem now they're facing. That's the one main reason, one of the reasons that I can think of. And how long must we wait after a COVID? Remember, when you get a vaccine, you have antibodies. And now, when you get your vaccination, they will always ask you the question, when was the last time? There's a specific time, I think they say 4 weeks, in a 2 month or no 1 month, where you diagnose with the vaccine, with the COVID. So when you say yes, for sure they'll be saying no. Wait for maybe for 2 weeks to come back, and then so. And then I think, as I indicated earlier when we were talking of me and you, the immunogenicity. People who understand immunology a lot, they will tell you it's something to do with the antibodies. Remember, when you get infected, there will be some complication with the antibodies and stuff like that. So the antibodies are already out there. So you need to be in a certain, maybe some period to wait and then come back, and when the antibodies can be triggered again.
Okay, let me just quickly go to perhaps the last patch of questions. You touched on the issue of development stages, and I see another question that is related to that is, with COVID-19 vaccine, where are we on those development stages? That's the question number one. If you can just jot it down. I'm going to the next question. What causes people feel like there are painful things moving in their body after taking few hours of taking the vaccine, both male and female? That's the second question. The DNA vaccine, can it change your origin DNA? And another question here is it advisable to take vaccine when you're not feeling well? For example, if your blood pressure is high. The other question is, the process seems to be long, as you're explaining. Dr. COVID-19 came too quick than you are explaining. What could be the reason? Is blood loss a truth reaction after the vaccine? Are the vaccine for bacteria? I think those are some of the questions that I would like you, because some of them I think you've answered.
You'll remind me. Let me just, how far, the first one, I think, how far are we with the development of COVID?
So with COVID-19, where are we on those development stages? Remember, you touched on the presentation.
No, I think now, remember, many of these vaccines have been licensed. So we are on phase 4 now. People are being given these vaccines. It's done. Although there are some vaccines that are still under construction of other vaccines being studied. But the ones that we have now, you are Moderna, you are JJ, you are whatever, you are Pfizer. All those diseases, all those vaccines have been approved. So which means we are on phase 4. Phase 4 are meaning like any difficulties that we can encounter, it will be registered and then is being evaluated. The regulators of this vaccine they are recording. If you are having the thing, and they will like, maybe there's one case of a blood clot or 2 cases of blood clot, it's being and then they study them. They say, okay, no, wait. Remember, there was a time where certain vaccines were stopped to be given to people.
Yes.
They were stopped because it's a process of saying, no, we have picked something. We are on level 4 now. People are getting it. And remember, I mentioned to you that people who get to these clinical trials are healthy people. So when you give to the masses, it's everyone. So some people have got their own difficulties. And then they decide, are these diseases or conditions we are seeing now, experiencing, are they related to this vaccine? And if no, that's when the green light will be given to say, no, carry on, do the thing. Because I remember the issue of blood clot, it was on a certain age in the USA people between 25 and something. And when they study them, they find, no, these people, they've got this. You see, so there's no. This has got nothing to do with it. But although it has been triggered by the vaccine, but it doesn't have nothing to do with the vaccine. It's not like everyone who get the vaccine will be getting this blood clot. And the things moving in our body after vaccination, I think it's just solved because remember we say side effects are the reactions that you are seeing after after you injected. Mm-hmm. So yes, so remember this is, as I indicated, you are mimicking the process of antibodies being produced by the body. You are mimicking. So when you mimic, the body will react. When it reacts, it produces things out. When it produces things out, before they can work, they have to do something in your body. That's why you have got a headache, dizziness, and all those things. And one question that I think I heard correctly because I was unable to note it down, the issue of why did it take, it's a process, it's a long process. But with the COVID vaccine, they came 2 years or something like that. So it's like, look at the tender process. They will always say when there is a disaster, you cut, you get exempt from the certain, what do you call this? You get exempt from the certain procedures. So it's the same thing with the vaccine. So this vaccine, we call them emergency, and it's like vaccines which were developed under emergency. And if you can follow the news also, you will remember there will be statement that this vaccine will not be getting whatever they, what do you call this? What is IP? I forgot IP. When someone owns something, they say, no, we are not going to follow that because of this, because it's a process to have those things. And you must remember, I said on that development process, yes, you have to submit data to a certain regulators, and they have to look for, maybe they will say, no, we are meeting in July to look at this data. So for now, because it's under emergency, everything is done under emergency. So there is things are still done the same, but at a rapid. That's why they say rapid development of vaccine. Is this what we are seeing now? There's nothing changed. It's just that everything is being done rapidly.
So this is our last two questions, which was, is it advisable to take vaccine when you're not feeling well, for example, if your blood pressure is high? And the last question, but not least, is after contracting COVID-19 virus, is it still important to vaccinate since your body has developed antibodies? I mean, if you have, you had a COVID-19, and then is it, if you can just go into that answer.
Okay, this one, I think it also differs with the people. Some people, they'll tell you that I got a vaccine, I got thing, but I never got infected again. Some people will get infected again. And with this, remember, as I just finished talking about the rapid development, there will be many things that will be discovered on the way with these COVID vaccines. But to mention that, I think when you got it before, I will just advise that you got it, yes, but don't trust that you are immune to it now. Just go, because some people, they'll tell you, I've been infected twice. Yes. I infected 3 times. So it's better to be advised to go and get a vaccine if you are willing to get it. And do you need to take these vaccines if you are not feeling well? I will suggest that no, if you're not feeling well, wait until you feel well, because remember the side effects are there. You're putting your life in danger because you are not feeling well, and then here comes the headache, here comes the dizziness. So you see, you are putting yourself in danger. So from my side, I think I won't be advising anyone who's not feeling well. Even the people who vaccinate you there, they give you a form, if I'm not mistaken. That form will be always saying, no, tell us, have you done this before? Were you diagnosed with this? If you have diagnosed, so which means you won't be able to get it, yeah.
Yes, Doctor, we're just coming to our closing of the program, and I see Tsepo Mavundza wants to ask a question. Tsepo, I'm giving you 15 seconds to ask a question. If you could go straight into the question.
No, thank you. That's well, my 15 seconds is gone now, but
it's gone
please,
already.
forgive me. I just want to thank you, this, and thank you, Dr. Mavundza, for the enlightenment. But lucky enough, I'm not speaking on behalf of Dr. Mavundza or Des or Bold Moves. But lucky enough, today earlier, I was at one Zoom session, with the international doctors in India. And I just want to sort of add on what Dr. Mavundza said, or maybe have a little bit omitted on the efficacy, I think one doctor from Geneva said, if we say a vaccine has 95% efficacy, if we have to put it in layman's term, and Dr. Mavundza is allowed to correct me if I'm wrong. If we say the vaccine is 95% efficacy, that basically means of 100 people that will be vaccinated, 95 will be saved, and 5% might or might not. So, but that is also consistent with the number of vaccinated people. Let's say, for instance, now we vaccinate 10,000 people. Mm-hmm. That means 50 people might not be saved, and what's that number? But as it goes, so if you vaccinate 100,000, then it means 5,000 won't be. So I just wanted to explain on the efficacy, because some people think that if the vaccine has 95% efficacy, it means in your body, you will be 95% okay, and then there will be just 5% that won't be okay. So I just wanted to clarify that one very quickly. Thank you.
True.
No, thank you, Tsepo, for coming in there to give us a clarity on that. We really appreciate that. Doctor, I'd like you to give you this opportunity to have your closing remarks before we close, because I see the whole thing of the issue of vaccine. It's an issue that we'll not be able to discuss it in a day. We'll probably need a week and a month, to go more into vaccine. But I think we have done justice today with the information. And I must say, we appreciate your time. We appreciate your time that you've put in putting together the presentation to teach us more about the vaccine. If you could just have your closing remarks before we close, Doctor.
Okay, my closing remarks are this, Desmond, and the viewers, and also the listeners. I would like to encourage people to seek their information, especially our people in the villages. Seek your own information. Don't be lazy. It's very disturbing to hear people talking on the WhatsApp. People saying, when we're growing up, we were told to believe that there is a hammer, which has got the worms. I never saw that thing. There is a shingunguma somewhere. There's nothing like that. I'm old now, and I'm getting my pension soon. I never saw a shingunguma. So what I would be telling people about the vaccines, just go and do your own investigation. And the pages to do those things, please go to World Health Organization pages, learn about vaccines. And the other thing, these vaccines, they're not coming now. We have got more vaccines in our bodies. If you are against the vaccine, but you are still taking your kids to the clinic for shikalu or for a weighing, it's a waste of time, because the vaccines are still in your body. Yes. And the last part, since it's a Women Month now, there is a part which I think it speaks to me, because I'm doing a little research. My research interest is on HPV. I will encourage our ladies or our women to do the cervical cancer screening. Please do the cervical cancer screening. It's very vital. HPV, it's very dangerous. It can kill you. It can end your marriage, because it affects all your reproductive organs. That's what I can say. Thank you, Desmond.
Doctor, I just want to say thank you very much for coming into and for allowing us to be here. And my apology for I know this was supposed to be done done by 8:30, and we have dragged it, but I
No,
believe
it's fine.
for a good cause, for us to get more information. And I think we're going to have this kind of a discussions, maybe perhaps in future, focus on certain elements that we could not touch on them tonight because of time. I say thank you very much. And also thank you to Pastor Strike for giving me this opportunity to host the conversation. And I think I'll be hosting more of the conversation with the listeners and the viewers of the Bold Moves Radio and or the Bold Moves Radio. So thank you very much, guys. Good night. Thank you, Doctor.